In this section, we are going to learn how to solve an equation where the variable, so what we're trying to find, is going to be part of the exponent. So below you will find the steps for solving an exponential equation. Now these are the steps you would follow if you can make the left and the right side have the same base. So step one is you want to isolate the power. That means you want to get the number with the exponent all by itself. So if we take a look at number one, step one, we can skip. Okay, then step two, it says rewrite each side of the equation as a power of the same base. So we have to look at both sides and ask ourselves, can we change the 3 and the 27 to the same base? So for example, on the left side, we can keep that as 3 to the x. And we can change 27. Instead of 27, 27 is the same thing as 3 to the third power. So that was step two. We want to change them so that they have the same base. So a good thing to try is take the smaller number and see if the bigger number can change into that base. So since the smaller number in this problem was 3, I try to see if I can take 3 to some power to make 27. So that was step two. Step three is once they have the same base, set the exponents equal. And then step four is to solve. Well, this one was a little bit easier. It already has x by itself. So that is our answer, x equals 3. So I'm starting off easier, and then each problem will get a little bit harder. So this is more of a basic exponential equation we're solving. So the very last step is we're going to check our answer. So we're going to take the 3 we just got and plug it in. For x. So instead of x, we're going to put a 3 right here instead of that x. And then make sure we get the same thing on both sides. So 3 to the third power is 27, and it works. All right, let's try example 2. So the first step is we want to get the power alone. So we want the 2 to the x all by itself. So we're going to go ahead and subtract 5. And then we want to remove the 4, and since the 4 is being multiplied, to undo this, we have to divide, because 4 divided by 4 is 1, so this will go away and just put a 1 in front of the parenthesis, which has no effect. Okay, so all of that was step 1. Then step 2 is see if we can rewrite the problem so it has the same base on both sides. So I'm always going to take the smaller number, which is 2, and see if I can rewrite 8 so it has a base of 2. So I can take 8 and write it as 2 to the third power. So I'm taking out 8 and replacing it with 2 to the third power because it has the same value. Okay, so that was step 2. Step 3, set the exponents equal. And step 4 is to solve, which it already is. So we have what x is. And then step 5 is to check our answers. So we're going to replace the x with the answer we got, which was 3. Exponents first, then we multiply, and we add 5, and it works. We get 37 equals 37. All right, let's try example 3. So the first step is we want to isolate the power. So in this problem, we are going to skip that step because the exponent in the base is already by itself. Step 2, we want to rewrite each side so that the equation has the same base on the left and the right. Right now, it has a 16 with an exponent, and it has a 64 with an exponent. We want them to have the same base. So we want this number and this number, the 16 and the 64, to be the same. So the first thing I try to do is I think about, can I take 16 and write it to an exponent to make 64? In this particular problem, unlike the first two problems, that is not possible. Okay, so now I'm going to take the smaller number first. And I'm going to think about, let's see, 2 to what power is 16? 2 to the 4th power is 16. 3 wouldn't work. There is no exponent that would give 16. 4 would work. 4 squared. So I need to either pick 4 or I need to pick 2. So then we're going to go to the 64 and ask ourselves, can I use 2 to any power to make 64? So 2 to the 6th power is 64. So 2 would work, but also 4 would work. 4 to the 3rd power is also 64. So it doesn't matter which one you pick. So we need to replace the 16 and the 64 with either 2 to the 4th and 2 to the 6th, or 4 squared and 4 cubed. So it doesn't matter which one because they both work and would have the same base on both sides. So I'm going to go ahead and use 4 squared. So 4 to the 2nd power is 16. So I'm taking the 16 out, but everything else remains the same. I'm going to take out the 64 and replace it with 4 to the 3rd. And I'm going to put parentheses because I'm substituting it in place of the 64. And everything else stays the same. So that was step 2. Making both sides have the same base. So now we're ready for step 3. Step 3 says to set the exponents equal. So since the bases are the same, therefore their exponents must be equal. So step 3, we're going to take 2. And remember, the 2 is inside parentheses, and we know from chapter 6 of this class that when you have exponents in the inside and you have exponents on the outside, you multiply. And then a 3 times an x over here. So that's step 3, set the exponents equal. Step 4 is to solve that equation. So we're going to distribute here. And we're going to get the x on the right side, so they're on the same side. And then we have x by itself. And then the last step would be to check our answer. So we're going to plug in -2. We have 16 to the -3rd power. And then 64, we're going to plug in the -2 here. And then we would put that into our calculator and make sure that they equal the same value. And when we put them in our calculator, both sides have the same value, about 0.000244. So then we know our answer is correct. Now to reiterate, we didn't have to use 4 as our base. We could have instead taken out the 16 and written it as 2 to the 4th power. Brought everything down. And then we could have written 64 as 2 to the 6th power. Then we would have set the exponents equal. Same thing we did the first time. Distribute. Put the x's on the same side. Divide by 2, and we still get -2 for x. So there might be two different ways to get the same answer, more than one correct way to get the answer, as long as the number we choose, in this case we could have chosen 2 or 4 to replace the 16 and the 64 with. On example 4, the base is already by itself, so we're going to go ahead and skip step 1. Step 2 is we want to see if we can make both sides have the same base. So I always start with the smaller number, and I need to think about, can I use 25 to any exponent, make 125. So you kind of try it out with your calculator and you see that that is not possible. So now we have to think of a number that they both can change into. So for example, we have learned about negative exponents in this class. So 5 squared is 25, but it's 1 over 25. So I know I can make the exponent -2. And then I think about 5. To what power is 125? So if you don't know, try in your calculator. 5 squared is 25, and 5 cubed would be 125. So I can rewrite this problem so they both have a base of 5. So what we are doing essentially is we're taking out 125 and replacing it with 5 cubed, and then the x gets brought down. And then instead of 1 over 25, we're replacing it with 5 to the -2nd power. And now that they have the same base, we are going to set the exponents equal. So this was step 2 that we just did. And step 3, once they have the same base, we set their exponents equal. So we'd have 3x equals -2, divide by 3, and we get that x equals -2/3. So to check this, we would take the x out, we would put -2/3 in for x, and then we could go ahead and put this in our calculator. 125 to the -2/3 power, that would be 0.04. And then we would put 1 over 25, or 1 divided by 25, into our calculator, and it is also 0.04. So our answer is correct. All right, example 5. The first step we can skip because the power and the exponent are already by itself. Step 2, we need to rewrite each side so that they have the same base. So I'm going to take the smaller number and think about, can I take 4, any exponent, and get 8? And the answer is no. 4 to the 2nd power is 16. So that doesn't work. So 4 won't work. We can't make both sides have a base of 4. So now we have to think of another number that could work. So I know that 2 to the 2nd power is 4. So I'm going to try that. So 2 to the 2nd power is 4. Now I need to see, can I use 2 also on the right side? Is 2 to any exponent 8? And the answer is 3. So since we found the same base, it's 2, We can change both sides to have a base of 2. We can take out the 8 and write it as 2 to the 3rd power. And we could take out 1/4 and write it as 2 to the negative 2nd power. Because 2 squared is 4, if we want 1/4, a negative exponent would move it to the denominator. So we need -2 there. Okay, then we're going to put it in parentheses. This x here is going to stay there. And that was step 2. Step 3 is we're going to set the exponents equal. So we're going to take -2x and multiply them, because that's our rule when we have exponents inside and outside, and then equals 3. The reason why we are ignoring the 2's are because they're already the same. So we want to now make the exponents the same. We want to find out what does x have to be to make them both the same. So that is why we're ignoring the 2's and just focusing on the exponents. So step 4, we're going to solve this for x. And we get that x equals -3/2, or as a decimal, -1.5. So if we want to check this, we would take our answer, either the fraction or the decimal. We'd plug in -1.5 for x, and then we put it in our calculator, 1/4 to the -1.5 exponent, and we would get 8. So both sides are equal. Example 6, we're going to go ahead and skip step 1 because the power is isolated. So step 2 is we want to write each side of the equation with the same base. So I'm always going to start with the smaller number I see, which is 2, because I know I can write it as 2 to the -1 to make it 1/2. So I'm just going to focus on the 2 and ask myself, 2 to any exponent, can I get 32? So you have a calculator, you would try 2 to the 3rd is 8, 2 to the 4th is 16, but 2 to the 5th power will get us 32. So that's how I know I'm going to go ahead and use 2 as the power. So I'm going to go ahead and remove 1/2, because I can write that as 2 to the -1st power. And then the 3x plus 2 is going to stay there. And then we can remove the 32 and write it as 2 to the 5th power. And then that x is going to stay there. So that was step 2. Step 3, we are going to set the exponents equal. So remember, when we have exponents inside and outside of parentheses, that means multiply. We're going to go ahead and distribute. Then we want to get the x's on the same side. So we end up with x equals -1/4. And then when we plug that in for x here, we do 3 times -1/4, and then plus 2, which is 5/4. So when we put it in our calculator, 1/2 to the 5/4 power and 32 to the -1/4 power, the decimal values are the same. So we know our answer, -1/4, is correct. In example 7, we have to use step 1. So step 1 is we want the base and the exponent by itself. So this 4 here, we want to make a 1. So we're going to go ahead and divide both sides by 4, because 4 divided by 4 would make 1. So when you have a 1 in front of the parenthesis, it doesn't, when you multiply by 1, it doesn't have any effect. So that's why we divided by 4 here. And whatever we do to one side, we have to do to the other. So we're going to divide both sides by 4. And that was step 1. Step 2 is we want to make both sides have the same base. So I'm going to take the smaller number, which is 3, and I could take 9 out and rewrite it as 3 to the 2nd power. And now both sides of the equation have the same base. They both have 3. So now we can move on to step 3, is set the exponents equal. So we would have 5x equals 2, divide by 5, and we would get x equals 2 fifths, which is the same thing as 0.4 if you write your answer as a decimal. And then go ahead and check, and you should get that when you replace x with 0.4, or 2 fifths, same thing, you will get 36. All right, example 8. Step 1, we get to skip. The power is all by itself. So step 2, we have to try to make both sides have the same base. So I'm going to take the smaller number, which is 4, and ask myself, 4 to any exponent, can I get 32? And the answer is no. So we can't use 4 as the base in this problem. So then I think about the number 4, and I know that I could take out 4 and write it as 2 squared. And then this x here just gets brought down. And then I can take 32 out because I can write it as 2 to the 5th power. So that was step 2. We made both sides have the same base, which is 2. So now step 3, we set the exponents equal and solve for x. And we get x equals 5 halves, or 2.5. And then go ahead and plug in your answer and make sure that both sides come out to be 32.